Well, hello students. This is Dr. Barry Graham, your instructor in Humanities 231 and also 232. This is part of our Topic 1, Lecture 1, Escape from Reason, the Dilemma of 21st Century Culture. You will not need your textbook for this particular series. This will, since there's a series of 7 lectures, this should allow you plenty of time to pick up the textbook so that you have that in time for Topic 2. I want to give my grateful acknowledgement to a few people. Dr. R.C. Sproul, he's the author of much of this material that I'm sharing with you. Francis Schaeffer, one of the greatest Christian apologists of the mid-20th century, a personal mentor of mine, Dr. William Lane Craig, probably the greatest Christian apologist of the 21st century, in my opinion. If you go to YouTube, you can check out many of his videos there and the debates that he's done, discussions, interviews, and of course he's authored a number of books. And I'd be remiss if I didn't mention my late father, Dr. A. Hugh Graham. To be raised and mentored by such a great Christian scholar is something I'll always be grateful for. If you look on our campus, the big auditorium is named Graham Kennedy Farmer Auditorium, and that Graham on there is named for him. My thesis statement in this particular lecture series is Modern Culture Embraces Irrationality. Now, you may think that's kind of a bold claim. What I want to do is demonstrate by the truthfulness of this by giving some proof, just like you'll be called upon to offer evidence and proof for your thesis statement when you write the term paper for this class. So I hope to be able to kind of show you how that process works, and I think this will help you. One of the surprising things is that even the scientific community has embraced much of this irrationality. I'm not trying to pick on the scientific community. I'm just pointing this out because the scientific community has a lot of clout in our culture, a lot of influence. If you hear somebody say, well, that's not just a fact, it's a scientific fact, or if they start out a sentence by saying, well, you know, it's a scientific fact that whatever, fill in the blank. That's supposed to carry more weight and have more credence than something else, because if we say it's a scientific fact, then we mean that the scientific method is very reliable, and that offers a lot of proof for it. And it can. I mean, the scientific method is very valuable, and we're not putting down that at all. But there are those out there that believe that the only way you can really prove something is scientifically, by using the scientific method. What we want to remember is that even though the scientific community has drifted into this, the reason for it is the same that anyone drifts into irrationality. This quote from R.C. Sproul, even though it's paraphrased, I think is significant. When logic is negotiated, and that's exactly what happens. And so you can get into some of these myths and fables even if you're a smart person within the scientific community. A couple of the big words we want to learn in this series. One is epistemology. Epistemology deals with the science or the study of knowing. How do we know that we know what we know? That seems a little redundant, but we're just kind of driving home the idea that this is about the study of how we come to know things. We claim that we know things in our culture. For instance, you may have been to Wikipedia. Wikis are common out there on the internet. But it's interesting to me that wiki, and you may or may not have known this, wiki stands for something. It stands for what I know is. So in our culture, as in previous cultures, we claim that we know some things. But how do you know? How do I know anything? That's what the study of epistemology, or the science, the philosophy of epistemology, is all about. I want to share this quote with you. This is the first part of the quote. Science proceeds by having hunches, by making guesses, by having hypotheses, sometimes even inspired by poetic thoughts, by aesthetic thoughts even. And then science goes about trying to demonstrate it experimentally or observationally. Notice that they're mixing in the idea of poetic thoughts and aesthetic thoughts, even though we're supposed to be talking about science here. Finishing out the quote, they, or scientists, are seeing our science and technology not just as a matter of knowing things, but as a means of tuning in to the deeper questions of who we are and how we know what we know. There's that knowledge thing again there. How do we know what we know? This was edited by John Brockman. It's from a little small book entitled What We Believe But Cannot Prove. It's well worth picking up. I found my copy at Half Price Books. I'm sure you can find a good used copy on Amazon as well as maybe some other sites. But one of the reasons why I think it's really important is that we're talking about a group of different scientists writing chapters in this book, and it's with the idea that we believe some things that we can't prove, and that seems to run counter to the scientific method and to what scientists are normally saying. So we want to think about these kinds of things as we're examining epistemology. Even though it's the science of knowing, they're claiming here we actually think we know some things, we believe some things, but we can't necessarily prove it. So, the idea that the scientific method is the only way you can prove things is not really science, it's scientism. So there's a difference between science and scientism. Fortunately, most philosophers and individuals nowadays reject this notion. They used to call this verificationism, sometimes called logical positivism. You think about it, even the statement that only the scientific method can actually prove something, that statement can't be proven scientifically. You can't use the scientific method to prove the statement that the scientific method is the only way you can prove things. So it's actually what we would call a self-defeating statement or a self-refuting statement. So again, that's where logic has been negotiated there. Once again, just to kind of give you a big definition here, scientism is a philosophical position that exalts the methods of the natural sciences above all other modes of human inquiry. So the idea there is, even if it's not the only way to determine the truth or to offer proof for something, they might say, well, we believe it's the best way. One of the other big words besides epistemology that we want to look at is the word or the concept of ontology. Ontology means the study of being. That's what helps us to determine what's real. We would say we're not just humans, we're human beings. And the reason we use the term beings in there is that we're asking, what is it that makes somebody a human being? What's the nature of being human? So ontology is the study of the nature of being, existence, or reality as such, as well as the basic categories of being and their relations. We've underscored the word relations here because many times what we discover is these things only exist in terms of their relationship to each other. And that's what helps it to make sense. So we want to make sure that we put things together properly, that we even construct words together and properly in terms of their relationship with each other. Where this drifts into irrationality is this idea that, for instance, even in the scientific community, there are individuals who attribute personal ontology to blind impersonal forces. When does this happen? Let's look at this. Richard Dawkins, a very famous biologist, and also he's a famous atheist out of England, one of the foremost spokespeople for atheism today. But notice his quote here. He says, "Biology is the study of complicated things that give the appearance of having been designed for a purpose." So he's saying here, well, it may appear that it was designed, but it's actually not. When you see a bird flying, that bird may look like it was designed to fly because it's got wings and it's so good at flying. But Dawkins would say, no, it's able to do that because there's been billions of years for it to evolve, or at least millions of years for it to evolve. And so it just appears like it's been designed because of Darwinian evolution. But we have a right to ask, is Mr. Dawkins correct, Dr. Dawkins correct on that? Another example of this is what we might call the cosmology of chance. For instance, there are people that claim everything that is in existence right now happened by chance. The universe happened by chance. Given enough time, anything can and will happen. Notice this quote here by another very smart person, George Wald. He discovered the retina and the idea of vitamin D in the retina, and a lot of study of the eyeball. But notice this quote here: "Time itself performs the miracle. Given enough time, the impossible becomes possible, the possible probable, and the probable virtually certain." So given the fact that he would feel that the universe is billions of years old, that's enough time for anything to happen, and it does. But again, you and I have the right to ask, even though you're a smart person, Mr. Wald, is that really true? Even if the universe is billions of years old, does that mean that there's been enough time for everything that we see in the universe and all of nature and everything to just strictly have happened by chance? Sometimes this type of statement is misused or even misunderstood because it's thought, well, if the universe happened by chance, there's something called chance that caused it. Okay, but we all know that chance itself has no causative power, the word chance, or even the concept of chance. Chance is a legitimate term when it refers to mathematical probabilities, but they're subtly changing the meaning of the word here, or at least subtly misunderstanding the meaning of the word. And that creates a real problem here. It commits what we might call the fallacy of equivocation. The fallacy of equivocation is one of the many logical fallacies in which we identify some sort of irrational thought or irrational talk. There's a handout on logical fallacies at the end of topic 1 in your on the Schoology site there, so we encourage you to go ahead and look at that. We will be looking at it more in depth later, but if you want to get a head start on it, it's certainly there for you to check out. So where it commits the fallacy of equivocation is it subtly changes the meaning of chance. That's what the fallacy of equivocation is when you change the meaning of a word, maybe without knowing it or without the other person listening knowing it. You change the meaning of the word halfway through the discussion. Chance has come to mean the absence of cause or even the absence of causal power itself. But we know that that's irrational. Things can happen without a cause. And chance doesn't have any power in of itself. Chance has no material content. Once again, it's just simply a word used to refer to mathematical possibilities. Take, for instance, a coin toss. If I toss a coin, you might say, well, it came up heads by chance, or it came up tails by chance. And you would be absolutely correct in saying that if you mean that it happened because there was a equal mathematical probability that it would come up either heads or tails. That's correct. But there's nothing called chance that causes it to come up heads or tails. What is it that causes it? Well, it's the force of this person's thumb that flips it. And there's a certain randomness to it because he or she never flips it with exactly the same force, does he? You don't have enough control to do that. So that's why sometimes it comes up heads, sometimes it comes up tails. But we can easily imagine that you could invent a machine that would flip it with exactly the same power each time. And let's say that you also put a big clear dome over the top of it to make sure that no wind blowing or anything else would affect it. And if you flipped it within that dome with exactly the same force each time, you could make it come up heads every time, or tails every time, depending upon how much force that you could set it for, in this fictitious machine. All right. So we see that by saying it came up by chance is appropriate, but not if you mean that's what caused it. By chance in that case would be a misnomer, or misnomer means to misname something. We would be misnaming what we're calling chance there. And so this brings us to this conclusion that if we want to offer proof for something, we have to remember proof has rules. And these rules are called the laws of logic, or principles of sound reasoning. Sometimes they're called the principles of logic. And we're going to be studying these, because if we want to come to some true conclusions on things, we have to have proof, and these are what will give us that proof. Now remember, these are just tools, just like a carpenter has tools to build things. He or she might have a hammer or a saw or a tape measure, whatever it might be, so that they're able to build what it is that they want to build. In the same way, when you're thinking about coming to a conclusion as to whether something is true or not, you also have these tools that will help you build your case, to use that tool analogy. There's 4 of these. There's actually more than 4, but we're going to focus on the 4 that I think are the most basic. Number 1 is the law of non-contradiction. Number 2 is the law of causality, sometimes known as the law of cause and effect. Thirdly is the basic reliability of sense perception. And then finally, number 4, a lesser known one, it's the analogical use of language. Now, if these don't make a lot of sense to you at this point, that's perfectly fine. That's why we're going to take our next few sessions in order to go over these, to unpack them, and see what they all mean, and more importantly, how they can be used to provide proof for something and to come to some true conclusions. So we'll be picking it up on those next time. One other thing that I might mention to you is if we're able to do some live conferencing using Schoology, and it does have that capability, we might, just for fun, try some game show type of software, or it's actually a site rather than software, but it's called Kahoot.it, Kahoot it. And there's also an app, a Kahoot app, if you want to look on your iPhone store or App Store or Google Play. You can go ahead and download that to your phone if you want, so that you can be ready. But it's just something to play for fun, because a lot of people kind of like that game show format. So we will pick it up there next time with Lecture 2. We'll have that uploaded for you very soon. Thank you for watching this, and we'll pick it up next time.